Hello and welcome to the second module of our course, Vector Processing with QGIS and GeoPandas. In this first video, we will introduce what vector data is, how it compares to other types of geospatial data, and why it is essential for planning and optimize energy systems. Before diving in, let's clarify something important. In geospatial analysis, there are two main types of data structure, raster and vector. In this module, we will focus on vector data, but understanding the distinction is crucial. So, what's a raster? A raster is a grid. Imagine a matrix of pixels where each pixel holds a value. This type of data is used to represent continuous phenomena such as wind speed, temperature, or solar irradiance. Raster data is ideal for environmental layers and satellite imagery. We will explore rasters in depth in the next module, where we will learn how to process and analyze them to estimate renewable energy production over large areas. But for now, let's focus on the other major data type, vector data. Vector data is composed of discrete geometries, specifically points, lines, and polygons. Each of these represents specific objects in space. For instance, a point might represent a weather station or a bus stop. A line could be a power line or a street, and a polygon might define a municipality, a building, or a solar farm. These geometric entities are associated with attributes. For example, a wind turbine point may have fields for rotor diameter, installed capacity, and commissioning year. In energy system analysis, vector data helps us define constraints, such as protected areas and land-use zones, and perform spatial reasoning. How far is this site from the nearest substation? Is it inside an industrial area? Can it be accessed via existing roads? To work with vector data, we will use two main tools, QGIS and GeoPandas. Let's briefly introduce them. QGIS is a mature open-source geographical information system platform with a graphical interface. It is widely used for cartography, spatial exploration, and visual workflows. It allows you to layer, style, and edit vector data with ease. On the other side, GeoPandas is a Python library that brings the power of spatial operations to the data science ecosystem. It is particularly useful when you need to automate processes, handle large datasets, or integrate spatial data into analytical pipelines. While QGIS is ideal for manual exploration and map production, GeoPandas shines when it comes to reproducibility and automation. Choosing between the two depends on the task, but more often than not, they work best together. Let's consider some concrete examples in the energy domain to better understand how vector geometry translates into real-world applications. A point layer might represent the exact location of photovoltaic installation, each point storing metadata like installed capacity, commissioning year, or orientation. A line layer could represent the national or regional transmission network, mapping high-voltage corridors, pipelines, or road access routes. And a polygon layer could define boundaries of urban areas, land-use categories, or regulatory exclusion zones, like protected environment areas or military domains. Working with these vector layers allows us to perform critical planning tasks, for example, site selection, proximity analysis, conflict identification. Site selection. Is the proposed energy system located within a valid land-use category? For instance, is it in an industrial, rural, or agricultural area? These designations can determine whether energy projects are feasible or even legally permitted. A very common use case in urban energy planning is estimating the available rooftop area for solar PV installation. By extracting roof polygons from cadastral or elevation-based layers and then excluding shaded or inaccessible sections, we can estimate the effective usable surface. Proximity analysis. How far is the site from the power grid? Are there access routes within a feasible distance? Conflict identification. Is the selected location overlapping with a protected area or with a legally excluded zone? These operations all require structured, spatially aware data, and this is exactly what vector formats provides. That's why vector processing is a foundational skill in geospatial energy analysis. Mastering these tools allows us to go from scattered data to integrated energy models, ready to support strategic choices on infrastructure, site selection, and policies design. In this introduction, we clarify what vector data is, why it is useful, and how it differs from raster data, which we will explore fully in the next module. We also introduced the two main tools we will use, QGIS for interactive vector operations and GeoPandas for scripted spatial analysis. In the next video, we will start working hands-on. You will learn how to join datasets, build buffer zones, merge geometries, and compute distances. See you there!